Alright, so let's start with today's class. So we were doing nuts and bolts in the previous class. Okay, so we have already done square-headed nut and bolts. Okay, now we'll see how to do the drawing for a hexagon-headed nut and bolt. Okay, right? So the thing over here is that if you look at the hexagon nut and bolt, it is going to be something like this as shown over here. The head of the bolt should be hexagon in shape. Similarly, the nut will also be in hexagon in shape. In the question, what they will give is that only the diameter of the bolt. Okay, they will tell you to draw a hexagon nut and bolt with its front view and top view, whose diameter is some 20 mm. Okay, that's all they will give, right? All the other things we should remember how to draw, right? So there are certain formulas specifically meant for the to draw the nuts and bolts. I'll tell you that as I do the drawing, right? Okay. So what is that? We'll see that. Okay. Right. So how to draw this nut and bolt? All they will give is only this particular thing, which is the diameter. Only this thing they will give. Right. Remaining all other things we have to draw. Right. Okay. Next comes what? Right. All right. Okay. So now look here. If we have the diameter of the bolt that is given, let us assume the diameter of the bolt is 20 mm. All right. Okay. Can you hear me? Hello? Hello? Okay, all right, fine.
Yes,
So,
yes.
right, okay. So now with the diameter of 20, we'll try to draw a hexagon nut and bolt. Okay. So now to draw the head of the bolt, see this, the head of the bolt should have a diameter of 2 times the diameter of whatever that is being given. Okay, 2 times the diameter, right? And it's similarly for the nut also, the overall thing should be 2 times. But when now in a hexagon we have two things. One is we have two opposite edges and opposite corners also we have. Now when we are going to keep resting on the corner of the hexagon nut, okay, then it is going to have 2 times the diameter. That means this length, okay, this particular length is going to be 2 times the diameter. If it is the flatter end, it is a different case. Okay, it will not be the same thing. Okay, 2 times the diameter. Right. Now we'll see how to draw this. Okay. So okay, and diameter of the bolt and the length of the bolt will be given. Okay. So we'll assume diameter of the of the bolt to be 20 mm and the length of the bolt to be 100 mm. All right. So now let us see how to draw that. Okay, I'll just zoom in this particular place and I'll draw first one axis line. Okay, let me draw one axis line. Axis line, right? Okay, so axis line at 0 degrees. Okay, now what I'll do is that I'll first draw one a line over here, anywhere over here approximately. Okay, and what I'll do is I'll take 10 mm is the height. Okay, 20 mm is the diameter. No, all right, fine. Okay, so what we can do is see what is this. Let me go back here. The total height over here should be 2 times the diameter. That means from the axis, if the diameter is 20, okay, then from the axis, the height of the bolt measuring from the axis is half of that. That means only D. That is 20 mm, and here another 20 mm, right? And then what is the thickness? It is going to be 0.8 times the diameter. For usually the bolt heads will be 0.8 times the diameter. That will be the thickness of the bolt head. Okay, 0.8 times the diameter. So we'll directly go with that. Okay, so let me draw that. So diameter is 20, so half of that, I mean, totally it's going to be 40, so I'm going to take only half of that, 20 mm. Okay, and 90 degrees, yes. Okay. Okay, okay, it's here, all right. 20 mm, angle 90 degrees, 0.8 times 0.8 into diameter. How much is the diameter? 20 mm, right? Right. So that is going to be about 16 mm and at 0 degrees. Okay. And then what we can do from here, it's going to be 40 completely down. Okay. And at an angle of minus 90 degrees, sorry, 40 mm minus 90 degrees. Okay, and this will be for 16 mm, nothing but 0.8 times d, and close this. Okay, and close this. Now, from here, what I can do is I can just, uh, if at all I need, when you're doing it on a scale, you can keep your scale here, measure for a height of 10 mm and draw one horizontal line over here. After 10 mm, you can draw over here. Okay, right? So on the system, what you can do is either you can go by offset method. So I can offset this. I can go by a height of 10 mm, right? Keep it here and trim this portion. Okay, trim this also. This line length should be 100 mm. Sorry. Should be 100 mm. Right. So here I'll make it again continuous line, and then I'll go for this. And here at the end of that, I'll just get it down until the axis. Okay, right? Okay. Now what I can do, what I'll do is that, okay. So the next thing is that, say for example, the thread length will be only for 50 mm. Okay, so we'll offset this by a distance of 50 mm. Right. Then over here, it has to be a chamfer for 45 degrees. Okay. That means how much did we get last time? I think it was 1 mm by 1 mm or 2 mm. Look here. Okay, 2 mm, right? Okay. So, so what I can do here is that I can go inside once again by a distance of 2 mm. And here, okay, here also it is 2 mm only. So I'll go for offset, again 2 mm. Okay, and here what I can do is that and then I can trim off the unwanted regions. I can trim this. Okay, right, let it be as it is for now. Okay, so now this same thing. Okay, then after drawing, I've drawn only one half of it since I'm doing it on the system. Okay, all right, so yes, and all right. right? So let me take this length from here. Let me offset it by a distance of, say for example, some 60 mm. Okay. Right. So for this, okay. So this portion, what now I'm going to draw is for the nut. Nut will be 0.9 times the diameter. That means 18 mm. Okay. In this case, at 0 degrees, and this length will be 40, and here. Okay. So this will be 19 mm. Sorry, 18 mm. This will be 16 mm. Okay. Right. Okay. Now for this, here what we have to do, it's a hexagonal nut. Okay. So say for example, I'll just draw one hexagon roughly. Okay, this is the front view. Okay, this is the front view of the nut or the bolt head. Okay, 1 second. All right. So now, when you look from here in this particular direction, from here, okay, what can we see from the side view? If this is the front view, I'm going to look from here, from the left side. I can see one corner, second corner, third corner, fourth corner. That means I can see one line over here and one line over here. Okay, right? I can see 1, 2, 3, 4 corners totally. Okay, out of 6, I can see 4 corners. So this is one corner which is on top side. This is another corner on the bottom side. So here I have one corner which is represented in the other view. It will be an edge, and from this bottom corner there will be another edge. So I have these two. I have to get these both. I have to get this, and I have to get this one. Okay, so where will this be? Okay, where will this be? Right? Where will this be? Is the question, right? So what will happen is that, okay, in this overall length, okay, what we will do is that, so how to get that is that, now what we will do is, we'll take 1/4, we'll make it into 4 divisions. Now just look at this, I'll just draw the line, 1, 2. So totally 1, and here we have axis line. So first region, second region, third region, fourth region. Above the axis, 2 regions are there. Below the axis, 2 regions are there. Okay, so for hexagon, what will happen is that it will be in between this. How to make it into 4 divisions? Okay, okay. So here on this, it will be in between this over here, exactly at the midpoint, and here also midpoint on the lower half side. All right, right? Okay, it will be like this. So let me darken these particular lines so that you can see it correctly. it will be like this. Now for this we have to draw the uh, curvatures just like this. In the square headed nut and bolt we drew like this, right? So this feature we have to get onto the nut and bolt head. Okay. Now how to do that? Okay, how to do that we'll see. Okay, so for that what we can do is that we have to go for a 30-degree line. Okay, I'll show you here. So look here, what they'll do. What they will do is that, okay, so now the thing will be that it is going to be 30 degrees. Here it is going to be 30 degrees. Now how to get this 30 degrees? We should know the center. Now how to know the center? Okay, if here it is going to be 30 degrees, then just a second. Okay, all right. Okay, now how to get this 30 degrees? If it is here, we are going to have 30 degrees, then this angle is also going to be 30 degrees. Okay, right? That means from the corner. Okay, so for that, we'll draw one construction line. Measuring from here, from this particular corner at 30 degrees. Okay, right? So whose angle should be 30 degrees, just extend it. And even from here also, okay, any one end if you do, it is enough. Okay, any one end if you do, it will be enough. Okay, and okay, let me draw it from here also. Please draw all these construction lines. Okay, very thin lines. And from this half of this, I'll just show you that also. So from here, midpoint of this first portion, okay, from here, just draw one horizontal line. Okay, I'll tell you why we need this. And from here also. Okay, we need this. Okay, now just look at the drawing. Here 30 degrees from the corner, and also there is one horizontal line that is passing over here. Okay, exactly at the half of the first portion. Okay, we have totally four portions: one, two, three, four portions. Okay, so in the bottom portion and in the top portion, exactly in the half, draw one horizontal line so that we'll get the point O2, and O1 we'll get here where every line will intersect on the axis line. Okay, so now keeping this as center, we are going to draw this arc. Okay, and keeping this O2 as the center, we will draw this smaller arc. Okay, that is the manner in which we have to draw these curves. Okay, right? So let me go back there. I'll show you. Yeah. So here, go to arc by center. Okay, keeping this as the intersection point as our center. Okay, and this one as the radius. Draw an arc. Okay, and similarly, this intersection point over here on the first half, keeping this as center and this one as the radius. This also. Okay, and similarly, you can do here. When you're doing it in your compass, you can do it completely. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . Okay, so you can draw one complete arc, but on the system, you can do is you can mirror it off. So exactly the same thing you cannot do it onto the system. Okay. Mirror this features like this. Right? Okay. Is that clear? Any doubts with this step? Any doubts? Okay. Now with this, we have to do the same thing onto the nut also. For the nut also. Okay. Can split this. Okay, let me mirror this and this particular thing and all these features. Okay. And let me split it up over here. Right. So now when we draw a 30-degree line for this, okay, the same construction over here also. Okay. So we are going to maintain this at 150 degrees. Okay, and draw one center line from here. And draw the same thing at the center of this. Yeah. Now what we have to do is the same procedure. Go to arc by center. Okay. Here we can mirror it. Okay, by joining on one end. Okay, and let me draw one center line over here. And now I'll just mirror this portion, and then mirror this curve also. Okay. So let me darken this so that you can see. Okay. And yes, we can go to arc by circle, arc by center. From this intersection point, this is going to be the radius. Just a second. Arc by center from this particular intersection. And we can mirror this particular thing also. So when you do on the system, it is not going to be a problem. You can mirror these features. But when you do it on to the sketchbook, you have to be a little bit careful. This has to be extended. See, it will actually meet here exactly. If your drawing is correct, it will meet here. Yeah. These arcs will meet. Okay, and now what you can do is you can select all these arcs. You're doing it on the system, and then directly mirror this. See, because if you look at a nut, it will be curved features. These arcs will be there on both the sides of the nut. Okay, but not on the bolt. It will be only on one side. Okay. So just look at that. On both the features, usually it will be. Okay. Right. Right. So now we have drawn the front view. Okay. Now all we have to do is the side view that we have to draw. Okay. We have to draw the side view and the top view for this. Okay. We have to draw the side view and top view. Okay. So for that, what we can do is we can go for the top view first. Okay. And repeat the same procedure. But just look here in the front, you will get totally 1, 2, 3, 4 portions. But that is, you'll be able to see 1, 2, and 3 sides. But in the top, you will be able to see only 2 sides. That is just because of this. So if you just look at this diagram, so if you look from top, in this view, you will be able to see only 2 sides. One is this surface and the other one is this surface, right? So in between, you can see one straight line. Okay, right? So that is how the top view is going to be appearing. Remaining everything is going to be the same. So what you can do is that in the top view, for the top view, what you can do is that when you're doing it on the system, you can actually copy paste it. You don't have to draw it once again, but while you're doing it onto the book, you definitely have to redraw it once again. right? But there will be certain changes. Okay, we'll see what are those changes. Okay, right. So what are the changes that we are going to see in the top view? One thing is that the number of sides for the head is going to be different, but this width we have to get. Okay, without this width, what is this height in top view? We cannot do. So what is it going to be? It is going to be 1.5 times the diameter plus 3 mm. Okay, 1.5 times the diameter plus 3 mm. Okay, right? That is how it is going to be there. Okay, so if you're going to do the top view directly after drawing the front view, you can go here. Otherwise, you can finish the side view, then come to the top view. Okay, you can do it both the ways. Okay, right. So for that, so if we have, say for example, if we are going to do the side view, okay, side view, right? Okay. All right. So side view. Okay. All right. So for side view, what we can do is we have to draw hexagon. Okay, but we don't know what is going to be the uh, what the total height from the end to end, or what is the side length of the hexagon. We don't know. Okay, so without that, it is difficult to draw. Okay, we know only end to end distance. Okay, which is going to be 1.5 times d. That means 20 into 1.5, that is 30 mm plus 3 mm another extra. So 33 mm. Excuse me. So let us see if it is possible to do it. It's not here. Fine. Okay. All right. Okay. So the only thing is that we have to project. Okay, we have to project the lines. Yeah, we have to project the line. Right. So here we have another projection, right? So here yeah. So with this we are supposed to draw. So what we'll do is okay, so from here we'll take it. We'll just draw one horizontal line, sorry, vertical line, and from here it has to be how much? It has to be 33 mm. So to draw the hexagon, now it will be easy. Midpoint of this here. Uh, yes. Okay, right. So now I can draw one vertical line to so that I can have the center, and I can go for drawing the circle. Okay, diameter of the bolt is going to be 20 mm, right? So 20 mm diameter. Okay, and then we can go for arc circle by 3 points. And what you can do is you can go for again send arc circle. You can draw a circle by center. This should come correctly actually. Okay. All right. Sorry. Right. Usually it should come a little bit less than that. It's 34, not 34. It should be 33. Sorry. This circle diameter should be 33. Yes. Now it is correct. This is how it will be. And just like here, to show the threaded portion onto the side, we have to draw one smaller cut portion of a circle. Okay, that indicates it's going to be a threaded portion, right? So diameter inside this diameter will come, and it's going to be radius will be by minus 2 mm. So diameter is 20 mm minus 4 mm, that it will be 16 mm. You can draw this, and I can just draw one line, trim this portion. Yes. Okay. Now, if at all you want, you can keep this measurement. What is this height? Okay. And that's going to be for 40 mm. All right. But what is this length? This will be for 33 mm. Okay. Right. So this 33 mm is what will be visible over here. Right. So all we can do is that we can make these changes over here. Okay, for 33 mm. Just let me draw the axis line. Okay, so how much is this length? 10 and 10, 20. So actually we should have 33 mm. So 33, half of that is how much? 16.5. Am I correct? And then width is going to be the same thing only. It's going to be 16 mm. Make it dark. Okay, and this portion will be repeated on the other side also. right? So just look here. So here whatever is 2 times the D, it will not be here in the top view. It will be less than that. Okay. All right. Right. So here what we can do is we can project it from the top view. So this projection we can take it from here. Okay. One second. Yeah, sorry. Yeah. Okay, so let's continue here. Okay. So now for this thing, just look at the drawing, how they are going to do the arc portion for this. Okay, so they're going to take half of this. Okay, so I'll just draw it here to explain. So they're going to take half of this portion. So they're going to draw one line. Okay, and then they're going to uh, draw one straight line over here, bisect the straight line, take the midpoint of this, and then continue to extend it to meet this particular portion, that is O3 over here. Okay, so that is how we are going to get the radius for this arc. Okay, right? So that is how it is going to be done. Let us do that. Right, so they're going to take what? Midpoint, okay, construction lines, okay, right. Midpoint of this particular thing. and then they're going to connect it over here by joining a straight line. And then take midpoint of this. Okay, and take midpoint of this. Okay, so just look here. Right, they're just going to bifurcate that line and draw it. Okay, they have to bifurcate it and extend it. Okay, and extend it. Okay, so only then we'll be able to know what is the meeting point for O3. Okay, where this point O3 is going to come into picture. Okay, because this is not going to be exactly from the corner of the nut or the bolt head. Okay. So if you have to bifurcate this, then since we have to get the angle, we have to do this. No other go. You have to go by arc by center. Okay, from here, anywhere more than half of it. Let me take 6.3 mm as the radius. Cut an arc, and even over here also 6.3 radius, and from the opposite end keep the same radius. See, once you do it onto your sketchbook, you can measure the angle and remember those angles and copy it. Since I have not done it over here, I have to do all these exact constructions that you are going to do it on your sketchbook. Okay, so now join this. Okay, and extend this. And now you can measure the angle. If you are going to do it on your sketchbook, the angle will be somewhere at around 11 degrees. Okay, at 11 degrees. Okay, or anyway, perpendicular bisector, since it doesn't require all these things. Sorry, you don't need to do all these things at all. Even this is also not required. If you know the midpoint of this, you can directly go by from the center of this. From the center of this. Okay, just draw one line. Make sure that this is going to be at 90 degrees. Okay, and extend this. Right. That's all you have to do. Since it's a perpendicular bisector, you can do this. So now also it will be the same angle only, 11 degrees. Okay, right? So this you can do. And now what you have to do is that okay, now what are you supposed to do? All right. So here we are going to have arc by center. Okay. Keeping this as the center, this one as the radius. Okay. And then what you can do is you can just mirror this feature. Okay. And then copy this and this, mirror this feature onto the other end. Okay. Right. Okay. Now when I'm doing it on the system, what you can do is you can just offset this, all these features. Just a second, I'll show you that also. First, let me offset this particular portion by a distance of 50 mm. Single this particular line over here. Okay, so now the distance will be at around. Now what I'll do is I'll just mirror these features. Mirror these features. Okay, now what I'll do is I'll just draw this. I'll just complete it. Here it should be 0.9 times the diameter, so that means 18 mm. Okay, and 180 degrees. Close it, and this will be for a length of 33 minus 90, and then close this also. So here what I'll do is I'll just take the midpoint, just draw one line to mirror these features if at all, if it is required. So here they have not shown. So here they just stopped it with it. You can also stop, no need to mirror this. Okay, and this is not required, right? And this portion is going to be trimmed. And here it will be extended. This portion will also be trimmed because threading is there only for about 50 mm, not completely of the bolt length. Okay, and the same thing we have to change here also. And then yes, we can trim this. Right. Yes, any doubts, or you want me to repeat any line, anything? Hello? Yes, any doubts? Hello? Any doubts, or you want me to repeat anything?
No, sir.
Right. All right. Right. Okay. Fine. All right. So please draw the
Okay.
drawings uh, for hexagon nut and bolt. Square-headed nut and bolt, I've already done it in the last class. Okay, this here we have done this in the regular class in the last class. Okay, right, and then yeah. Right. I'll share this drawing for just a second. Yes, so look here, this is for, see this particular drawing. This particular drawing is for a square-headed nut and bolt. Okay, but in view nut and bolt in view cross corners. Okay, the corners are in the opposite. Okay, that means it is resting on its corner. Okay, so you can have a square-headed nut and bolt like this resting on its edge or resting on its corner. So if they are say cross corners, it is like this in a rhombus shape. Okay, all the other procedures remains the same only. Okay, right. So you please draw these drawings. See, look here also the same 30-degree angles have been taken up from the corner of the bolt head or the nut head. Okay, and even this bolt head will be 0.8 times the diameter, then nut head will be thickness will be 0.9 times the diameter. So you please draw this. Okay, I'll give you this as a homework, very similar to that of a hexagon nut and bolt only. All right, is that clear? Hello? Hello? Yes, any doubts? Any doubts? Or you want me to repeat anything? See, drawing will come only by practice. You will all have to draw it on do the manual drawing first, as well as practice it on the software also. Okay. Uh, so we'll go to the next chapter, okay, which is about the joints. So what if you look at these drawings, we first started with orthographic projections, and then we went to section of solids, where only single components or solids were there. And then we saw up to how to draw screw forms, thread forms, okay. And then just now we saw about how to draw nut and bolt. So nut is a different part, bolt is a different part. So two things how to draw in assembled, all put together, both of them put together, how to draw. So now we are going to the next stage where more than two components or parts are there involved, all of them which have to be shown how they are all going to be joined together. Okay, right? So one of them is called as a knuckle joint, what you are able to see onto the screen. Okay, I just zoom in this portion, the isometric view. So this is how it looks. Okay, now what is there here is that, see, this is one portion which is the this is the rod. Okay, and just a second. Okay, okay, all right. Okay, so this is going to be, see here, what you can see here, this is going to be the diameter of the circle. I mean diameter of the shaft that will be given. Okay, and this is going to be attached to it, which will be a forged component generally. Okay, that is this particular portion is a forged component called as the eye, which will have a hole that will be drilled at one end of it. Okay, and then you have the other thing as the pin, that is this particular portion. Okay, here is the pin, that is this complete, just like an cylindrical uh, rod with a head. Okay, it is called as the pin, this particular portion I'm talking about. Okay, and then here we have onto the other end of this, another shaft will be there of the same diameter. Okay, and again it will be joined to another portion which is called as the fork, that is this particular portion. Okay, which will have two, it will just get bifurcated into two. Okay, and to lock these two shafts, so shaft number one is here at one end, shaft number two is here at the other end. Okay, to join these both for a temporary joint, okay, we have to go with some kind of joining sections. One of them is called as the knuckle joint, and here we have a just like a bush which is called as a collar, which will be very thick. Okay, so this is the collar, and we'll have a taper pin for this. Here you can see a small tiny rod like structure which is called as the taper pin. So totally we have 5 elements coming into picture, all of them to be joined, okay, and it has to be assembled, and whose front view and top view have to be drawn. So in this case what they will give, first of all, a knuckle joint is used to join the shafts, usually generally long shafts, which will undergo rotatory motion. Shaft itself will undergo rotatory motion, right? So when it goes rotatory motion, okay, it must be and it when two rods have to be joined. So we cannot have a permanent joint, or we cannot make it into one single rod. That is the first thing. So it has to be joined, and this knuckle joint is a temporary joint. Okay, it's not a permanent joint. Permanent joints are like welding. Okay, when you join two rods or two plates and you weld it, it is a permanent joint. But these are not permanent joints. Okay, and this here we can have, say for example, I have one shaft at one angle and the another shaft at another angle. Okay, this is one shaft number one, shaft number two over here, and I have to join these both, and they have to undergo rotatory motion. They have to undergo rotatory motion. Right? They have to undergo rotatory motion, and it has to be joined. Okay, it has to be joined. So that means the joint over here in this, the joint portion should be flexible, right? It should be flexible. Have you all seen this anywhere, or something similar to this? Hello? Have you all seen this? Like this joint. Forget about this picture. Just whatever I explained. There is one shaft at one angle, another shaft at another angle. Both of them should be joined. Hmm? So next time, if you see uh, any, usually even in cars it is there, in the you can see it especially very neatly in the trucks. Okay, you can see that there is a shaft coming from the front wheel, that is actually from the engine, connecting to the rear axle. Okay, where you will see that there is a shaft coming at this particular angle and another shaft joining like this to the rear wheel. So there will be one joining element over here. Okay, and both this will undergo rotatory motion, right? And you can see this some kind of joining link that will be present, like two C's connected like this. Okay, which is actually a universal joint. Okay, so in such cases we need knuckle joints and all those things. Okay, right? So in those places we require this. So the question for this, how they will say is that they will ask you to draw the front and top view of the knuckle joint whose diameter is so much mm. That's all will be given. What is the thickness of this collar? What is the diameter of this collar? What is the diameter of this pinhead? All those details will not be given. We have to remember it. Okay, we have to remember it. Okay, so let me show you the diagram. Yes. So all this 1.2 times diameter, 3.7 times diameter, here it's going to be 0.7 times diameter. All these things we have to remember. Okay, we have to remember. Okay, without that we cannot draw. We cannot draw anything over here. Okay, now let us see how to draw this. Okay, let us see how to draw this. Okay, so here there are many ways to draw it. Okay, there are many different ways to draw it. All right, so I'll draw it in one of the ways. Okay, so the first thing that I'm going to take up is this I portion, which is over here. I'm going to draw this particular portion whose diameter let us assume is 20 mm. So here the eye should be 1.2 times the diameter. Okay, right? So that means it's going to be for 24 mm, and length should be for 4 times the diameter. Just look here, the length of the eye up to the axis, from the forged end to the axis, it's going to be 4 times the diameter. Okay, right? I'm going to take 4 times diameter plus, look at this, from axis line till this line ends. How much it is? It is going to be another plus 1 times diameter. That means totally 4 plus 1, 5 times the diameter. Okay, that means 4 into 20, sorry, 5 into 20, 100 mm. Okay, 100 mm. Right, so what I'll do is that I'll go here. See this, they may ask, and it's one question, complete marks. Okay, I think it's for about 25 marks. One question in part B. Okay, part A we have completed. We are going to go with part B. Okay, so what I'll do is I'll just draw one rectangle. Okay, and this should be for 100 mm, and this one should be for totally 1.2 times diameter. That means 24 mm. Okay, but I'll draw and keep it here. So let me draw an axis line for this. Okay, so this is going to be how much? This length is, I'll just offset it by one times the diameter. That means for 20 mm, I need this to be offset by 20 mm. Okay, and from here I'll just draw one line for 4 mm. I'll tell you why I'm taking this 4 mm length. And I definitely need it here also. Alright, see if it is there on one side, it is enough. Okay, right. So after this, what am I going to do? Okay, this is for 1 times the diameter inside. Right. Okay, axis was at as a length of, so this is going to be the axis line. Okay, because this portion is going to be 4 times the diameter, and from end to end it is going to be 5 times the diameter. Okay, right, so this is going to be the axis. Okay, so let me extend it from here, and okay, so let it be there. Let us see. I'll just extend it. Okay, right. All right, okay, so this I've drawn. So the next thing is what? So now I've drawn this particular portion of the eye from here it is going to be 0.7 times diameter. Okay, 0.7 times the diameter, but from where it is going to be, it is going to start exactly from here, 0.7 times the diameter. Okay, so or else how much is it going to be? uh, Diameter from here, another diameter, that is 20 mm. All right, so I'll just offset the axis line by 20 mm once again. I'll just offset the axis line by another 20 mm. Okay, and what I'll do is I'll just trim this. I don't need this one. Okay, this length should be only for this height should be for how much? 0.7 times the diameter. 0.7 into 20. Okay, angle 90 degrees. Okay, and here it is going to be there up to, yes, up to 40 mm, correct. Okay, 2 times the diameter. All right, to here it is going to be there, and here we will get it for about 2 mm below. Should be 2 mm and at minus 90 degrees. Minus 90 degrees, and here it is going to be for 4 mm. You will see why I'm taking this 2 mm, 4 mm and all when I start drawing the arc. Okay, right, so it is going to be like this. So what have I done? I have drawn this particular portion as of now. Okay, right, and above this how much do I have? I have 4.4 times diameter. Okay, so that is going to be at a distance of what from the axis? 1.5 times diameter. That means half of that, 0.75. Am I correct? Okay, 0.75 times the diameter. Okay, I will have. So I can just offset the axis 0.75 into 20 mm. Sorry. Right. Okay, so single here. Okay, so here how much is this length going to be there? I am going to draw this for a height of 0.4 times into diameter. It is going to be 8 mm at 90 degrees. Okay, and this one is going to be 1.5 times diameter. That means 30 mm. Okay, at 0 degrees, and get it down minus 90 degrees. Sorry, minus 90 degrees from here. Right, so let me remove this. Let me remove this. So just look at it. What I've drawn. I've drawn even this top portion also. I've drawn this top portion also. Okay, and now what is this bolt? Sorry, this the pin should be for a total height of 3.7 times d. Okay, in that you minus 0.4 times d. Okay, in that you minus 0.4 times. That means 3.7 minus 0.4, 3.3 times diameter. Okay, 3.3 3.3 times is going to be the length. Okay, right? And it is going to start from there. All right. Okay, fine. So we'll come back to that later on. We still have time for that. So let me go to this particular portion, which is this radius and curvature. So what I'll do is, so look here, this radius is at a distance of, is not exactly at the end of the eye or somewhere. From the axis, it is going to measure a distance of 1.2 times diameter. That means 24 mm. Okay, right? 24 mm. So what is this length? We already have 20 over here. Plus I've taken this 4. 24 mm I already have. Okay, I already have that. So all I need to draw is the circle or the arc. Okay, and similarly from here also, I'll only draw this because I've already drawn this. Okay, based on this only I've taken this 2 mm, 4 mm and all. Okay. Right, so this portion is over. Next, what we have to do, we have to draw this particular portion of curvature. But before going to that, let us draw this. So this end of the other end of the shaft, which is the fork, is for a distance of 5 times the diameter from the axis. Okay, it's at a distance of 5 times from here. So what I'll do is that uh, I can draw a rectangle starting from here for a length of 100 mm. Okay, and height should be this 20 mm only. Okay, height should be 24. Sorry, it should be here below. Length is 100, height is 24, so it will match here. Okay, I'll just only trim this portions, overlapping lines I don't need. Okay, and here is the next portion that I need to take it off. And now here I have to draw this curvature. See, here it has to go in this particular path like this, right? Okay, whose radius is 0.75 times diameter. Yeah, that means 15 mm is the diameter. Now, how to find the center for that is the question mark. Okay, how to find the question, how to draw. See this arc here, I'll just draw it in red color. This here it should be for a radius of 15 mm. Okay, but center is not given. What is the distance? We don't know. Okay, so how to draw that? I'll tell you. Okay, so for that, what you do is, okay, what you do is take a scale, draw a parallel line for a distance of 15 mm. Take this line from here, 15 mm, go above. Okay, right, and then from here, okay, just draw an arc from this center, right? This is how much? 24 plus 15. Okay, radius should be 24 plus this arc radius 15. Okay, now cut this. This is going to be the center to draw this arc, right? This is the little bit trickier portion that we will not, that is not given in the drawing. We have to do it. So now keeping this as center, radius is how much? 15 mm. Just draw it. Trim this. See here, you got this feature so smooth. Exactly. This is the exact drawing. This is how it has to be drawn. Okay. Right? Okay, this is how it has to be drawn exactly. Right. Yes. Now what are we supposed to do? We are supposed to draw this onto the other side also. So do the same operations onto the bottom side. I'll just mirror it. Okay. I need 1, 2, 3, 4, 5, then 6. This feature, right? And this particular feature also I require. Okay. Yeah, all these features I'll just off. See here, I got it onto the other side also. I'll only trim this. See, the eye is over, the collar is over, the fork end is also over. Okay, now this is going to be the pin head. Okay, and from here, let me extend this. Okay, so this should, I'll just offset it by a distance of how much? Distance of half of the diameter. Okay, so I'll just offset this on both the sides. Okay, let me offset one of them, then we'll see the remaining. So I'll just offset this half of diameter. That means diameter is 20, half of that 10 mm, sorry. All right. So now what I'll do is I'll just offset 10 mm on this side as well as, okay, on the other side also. Okay, and let me extend this. Okay, and so this length should be how much? 3 point. So just look here, it should be for a length of totally 3.7. Okay, 3.7 is from here and up to here. In that minus 0.4 times we have left. Okay, 0.4 times diameter. So this is going to be how much? 0.4, 0.4. All right. So this length will be for a total distance of, okay, that's going to be another 0.3 mm, right? All right, 0.3 mm. So from here it is going to be for a distance of 0.3 mm. So from here, let me draw it. 0.3 mm. 0.3, sorry, 0.3 into diameter. 6 mm is going to be the height at 90 degrees. And till here at 0 degrees. And it's going to reach this intersection portion, right? So this portion I don't require. Let me trim it off. Okay, right? So I've got this one also, right? And now I have to draw this pin, which is a taper pin, okay, where it says the length is going to be what? 0.25 times the diameter on the bigger end, and it is going to gradually taper by 1 mm after it crosses 50 mm. Okay, so after every 50 mm, okay, it will go down, the diameter will go down by 1 mm. The overall length is 1.8 times long. That means 1.8 times the diameter. Okay, so let me draw an axis line. One point eight into 20 at 0 degrees. And here it's going to be for a height of 0.25. I'm drawing only one half of it. Okay, so 0.25 in the sense Okay, or else we can do it like this also. What I can do is I can just draw one line 0.25 into diameter 20 at 90 degrees, and then I'll go to this center of this 1.8 times into diameter at 0 degrees. Okay, and now here what I will do is, here it is how much? It is 5 mm. So here what I'll do is I'll just take 5 mm. No, I'll just take it's 2.5. So I'll take 1.5. And here another 1.5 at minus 90 degrees. Okay. So I'll just make one point over here, half of it, so that I can easily fit it exactly. From midpoint, I'll just draw one line. Just move this portion now. I'll hold it at the center and place it here. Right? So just look here. The pin is also over. Okay. The pin portion is also over. Now what we are left out is that we are only left out with this curvature feature, which is 1.2 times diameter. Okay. Which is 1.2 times the diameter. Okay. So that means how much? This length will be for 24 mm. Okay. And it has to be divided equally. 1, 2, 3, 4 equal divisions. So that means 24 divided by 4, 6 mm, right? So 6 mm, right? So what I'll do is here, I'll just draw one line at 6 mm. Okay. And then this length will be for a length of 24 mm because 1.2 times the diameter. Okay, angle 0 degrees and lift it up. Okay, now I'll just do is I'll just go to fillet and fillet it off. Right, so this I can make the changes as per requirement and mirror this. See, to this length it's going to be 18. All right, so here also I'll do the same thing, 6 mm below. Okay, at 90 degrees. Okay, and from here 24 mm is the overall length. Okay, but we have to fillet it. Be careful, otherwise it's going to be only for 18 mm. Okay. I'll just fillet this. And I can mirror this option. Right? Sorry. Right. Isn't it? Okay, now all we have to draw is only the diameter of the shaft. Okay, so for that it's going to be easy from diameter of the shaft, right? So it's going to be 10 mm from here, 10 mm above, any particular distance for a shorter length. this. Then I'll go to this curve. Just draw an approximate curve. Yeah. And fill this portion. And do the same thing over here also at the other end. For a height of 10 mm, any particular distance. Okay, go to curve. Just in a freehand sketch, just draw this. Okay, just draw this. Okay, and fill this portion. Yes, so just look at it. So that's all. You know the details correctly, you can draw it easily. Okay, right? So this is the front view for the knuckle joint. Top view is going to be very simple. Okay, please try to draw that. Okay, and yes, we have to show the sectional view also. So here, what will get disappeared is that we can trim this portion here, here, here. Okay, we can just draw one. And in this portion also. And you can show the sectional view, whether it's hollow or solid inside. Okay, right? And generally for this, it will not be shown. See, right? And give the dimensionings. That's all is about the knuckle joint. Is that clear? Any doubts? Hello? Any doubts? Yes, any doubts? Okay, right. So please practice these drawings. Okay, it's very important. Okay, right. So we'll meet in the next class.